Hello and welcome to Physics Lesson 3.03 Part 2. We're still talking about adding vectors algebraically, but in this lesson we're going to look at some of the details that can come up that are a little out of the ordinary or a little different from what we presented in the last video. Let me give you a second to copy this down. So we have two vectors. We have vectors J and vector K. So here's vector J, it's 3 units long. It's got a 20-degree angle, and we're resolving against the vertical axis. That's not something we did last time. And in this one, vector K, 6 units, we have a 150-degree angle. What do we do if we go into 360-degree angles? How does that change things? So pause the video, copy this down, and I'll catch you after you're caught up. Okay. So a couple of things that we can do let's start off with vector K. Usually what you'll do is you'll always pick a vector that's directly with an angle off of an axis. And so if I was going to resolve this, I would probably grab the 30-degree complementary angle here. But let's just try it. And we need to get our coordinate system. So we're going to do up as positive. Why do I keep, isn't it always going to be up as positive and right as positive? And the answer is no. There's going to be times where it's going to be better to have down be positive or to change our signs. So for vector K, I'm going to put in 6 cosine 150. And I'm just going to leave, I'm not going to assign any sign. And I'm going to do a 6 sine 150J, because when we simplify it, I want to show you what would happen. Now, if I was doing the 30-degree angle, I would have to say that my first vector is going to, when I do the component, I would say that my Kx has to be negative and my Ky has to be positive. But look what happens when you punch this in your calculator. Punch in 6 cosine 150. Here's the neat part about that. It automatically tells you this has got to be a negative 5.19 I. So when you use the full 360, it gives you the correct signage. So why don't we do that in physics? Good question. A lot of times we're just working off of an axis. We really won't run into this after this chapter. I don't know if I've ever seen it on the AP test. And then this is going to be a positive 3J. All right, let's look at vector J. And I want to keep this one off of the vertical axis. So I want to resolve this the way it is, and I'm going to redraw it down here. So it's nice and big. I'm going to draw my axis in. And I said this is 20 degrees. When I draw in my components, I'm going to have to draw kind of the other side of the axis. This is going to be JY, and this is going to be JX. Do you already see the problem? Do you already see what changed? Remember, when we resolve a vector, we always do the horizontal first. It's always the horizontal. And then it's always the vertical. Look at my horizontal. Is that still a cosine function? Nope. For this, I'm going to have to say the sine of 20 degrees is JX over, we said this was 3 units, over 3. And for this, the adjacent angle, this is adjacent. Now my vertical is an adjacent. So this is going to be cosine of 20 is JY over 3. Now, they're both positive. So this is going to be positive and this is going to be positive. So when I write these in, for my vertical, I now have positive 3 sine 20I, and I have positive 3 cosine 20J. So the moral of the story is when you resolve against the vertical axis, your trig functions flip. Your trig functions flip. And you need to be aware of that because there's a lot of times where we're going to have to resolve against a vertical axis. So when I simplify that, that becomes positive 1.0. If I carry this out, positive 0.1036i, and this becomes positive 2.819j. And then I could add those and I could find the resultant. But really what I was after was, I wanted you to understand this, and I wanted you to see, now I don't know if I made it clear, if I had made this, if I had done 30 degrees and if I had made this 6 cosine 30, I would have gotten 5.19, but I would have had to have applied the negative. So this would have given me 5.19. So I would have gotten the same answer as the 150. When you do it with a 360, though, it automatically gives you your negative sign. Here I have to apply the negative sign. All right. The last thing I want to look at is what if instead of saying I want to add, so what we did here was we took vector k plus vector j. And again, I stopped short. I didn't do my components and resolve them into a resultant because I just, again, focusing on these things. What if I want to do vector k minus vector j? How do we subtract vectors? Well, it turns out that if I want to subtract vector j, I flip the vector. And I'm going to do this in the same color, but I'm going to do it in a dotted line. So this is j flipped. Basically, now I'm adding these two. From an algebraic standpoint, it's a lot simpler. So I'm going to start out with vector k here. So I'm going to do my subtraction here. And I'm just going to rewrite these in black. So vector k is negative 5.19i, positive 3j. So for vector j, all I do is I take my components and I flip the sign. So I'll take, instead of having a positive 1.036, I'll have a negative 1.036i, and I'll have a negative 2.819j. I sum them up and then I go on as usual. But to subtract, flip the sign. All right, those are three of kind of the nuances of vector addition. So again, what we talked about today was how do we handle angles in 360. Again, I usually change them, but you're welcome to leave them as like 150, 270, whatever. What do we do if we resolve against the y-axis? Our signs flip. And if we have to subtract, we just change the signs of the vector that we're subtracting and then proceed normally. All right, that ends 3.03. You now have everything in your toolkit to algebraically add vectors. Thanks for watching and have a good day.